Hi, I'm Mike Dewar. I'm the Chief Engineer of Red Valve Company. I've been here, it'll be 30 years in December. We have 4 different mixing systems that we'll talk about, but it all centers around this Tideflex check valve. So we got a grant from the US EPA to develop an all-rubber check valve to overcome problems with flap gates. So this is very similar in construction to a heavy-duty truck tire with different natural synthetic fabric reinforcement in it. And it operates solely on differential pressure. When there's forward differential pressure, this valve will let flow out. When there's reverse differential pressure, it'll prevent backflow. So there's millions of these types of valves, a lot on stormwater, wastewater outfalls, simply to provide backflow prevention and not require any maintenance. What I like to talk about is effluent diffuser systems here that utilizes the same Tideflex technology. With an effluent diffuser, this is the discharge of treated wastewater into streams, rivers, and oceans. And the reason multiple ports are used because you get much faster mixing and dilution. The issue is you cannot control the environment. These are installed at the bottom of the seabed and a riverbed, what have you. So if you have sediment transport, different things like that, salt water can intrude back into the ports. These used to have ports that didn't have any backflow prevention on them. While the outfall's flowing, that's not a problem. For a disturbance, if there's a storm, if there's surge, if there's a pump shutdown, what have you, you get backflow into this header pipe. If you get salt water and sediment into this header pipe, you reduce the hydraulic capacity and dilution efficiency. So we use these Tideflex diffusers not only to prevent backflow for the regular Tideflex. It's primarily backflow and to get as much water you out. Here, you want to maximize jet velocity. So we run a hydraulic analysis. We've tested dozens upon dozens of different sizes and stiffness variations of these. And we have a program now that we will provide all the hydraulics for effluent diffuser systems, which are needed to model the dilution of these systems. So we can provide the head loss, the jet velocity, the effective open area, the effective diameters for these. And we also make these with integral wire reinforced fittings. So this is an example of a wire reinforced elbow. When picture these are at the bottom of the river, if there's boat anchors or there's debris, there's submerged logs, anything that's plastic or metal can tend to break. Where these are now integral with the Tideflex diffuser, they can bend and deflect. And it's a variable orifice, so it opens and closes with increase and decrease in flow. So you get higher jet velocities at lower flows with a duckbill Tideflex valve than you would with a fixed diameter port. Next system I'd like to talk about is coarse bubble diffuser system. So we use the same Tideflex technology that we use for the other systems that operates on differential pressure. But these are coarse bubble systems now. These are installed in, for example, aerobic digesters, channels, sludge tanks, what have you. So we're able to use this manifold. We have a whole division that sizes the entire coarse bubble diffuser system. The advantage here is these are all blower fed. So if the blower goes down, if the power fails, these valves prevent backflow. The previous technology was perforated pipe or perforated diffusers themselves. If the blower goes down, the sludge packs the diffuser itself or can get back into the header pipe and clog the header pipe. So that's a maintenance nightmare. It takes a lot to actually get that sludge, especially if it dries in the hot air, to get all the sludge out of the header pipe and unclog the diffuser. So inherently, this Tideflex TFA coarse bubble diffuser is also a backflow preventer. So it prevents any backflow into the diffusers or the header pipe. So we also have a version of this that's hydraulic recirculation mixing systems for those basins in a treatment plant that are anaerobic, they don't have oxygen involved with them. We can do this with a recirculation pump. It's a similar type of manifold. We have a whole division with Red Valve Company that designs the entire system, provides the mixing analysis, oxygen transfer efficiencies, all that type of data that the consulting engineers need to do. The other advantage of this is it can be located very close to the bottom of the tank basin, where perforated pipe, because you'll have a sludge blanket down here, it scours the bottom due to the circulation patterns induced by the airflow coming in the tank, so it keeps a cleaner bottom and a less sludge blanket for these aeration systems. Next system I'd like to talk about is the Tideflex mixing system. These are the mixing systems we install in potable water storage tanks. So these tanks have historically been built with a common inlet-outlet pipe, which is a fixed diameter pipe. So for hydraulics, it gets the water in and out of the tank perfectly. However, that inlet pipe was solely responsible for mixing inside the tank. The problem with water storage tanks, especially in summer, is they can stratify, where you'd have the colder water at the bottom, warmer water at the top, and then the chlorine stratifies as well, where you'd have a detectable residual at the bottom and no residual at the top. So what this mixing system does is not only separates the inlet and outlet pipe. So there's water flex, there's a different type of check valve down here that's a water flex valve that gets installed in this direction, and then we have these Tideflex nozzles for the inlet. So when the tank is filling, it comes through the multiple jets to fill and mix the tank. When the tank is drawing, these valves are closed and water's pulled back through the water flex valves. This is a design similar to what's in the background, which is an elevated tank, a pedosphere type of tank. We do designs for all the different types of tanks: circular reservoirs, rectangular reservoirs, standpipes, and all the different types of elevated tanks. So we've done an extensive amount of CFD and scale modeling to determine where the configuration, the spacing of the Tideflex diffusers, the elevation, the discharge angles. We've done CFD and physical scale modeling to determine where we're going to place these valves, that during the fill of the tank, it will completely mix the tank. The advantage of it is there's already an energy source and the owner already paid for it. The single fixed diameter pipe was the problem. When you put a properly designed multi-port system like the Tideflex system in, it can mix the tank with the energy that they already have. This system will last 25 to 30 years at least. All these valves are NSF certified. We also do pass active, for example, with tanks in very cold climates and low turnover. We can actually use a recirc pump with this system and turn the passive system into an active system. So if you'd like any more information on any of these systems or any of the other products that Red Valve or Desura handle, please visit redvalve.com.